and talking about energy, electric vehicles, things like this. We've had him on before. Patrick Durham, great to see you, sir.
Great to see you too.
Okay, real quick, your website is, I have it on the screen here, Stash Training. I know where you get that from, probably, right?
Absolutely.
Real quick background on yourself. You do a lot of different things, but your expertise is in fire, but you're also an engineer. What's your background, really quick, for
Yeah.
everyone?
So I started off right out of college. I became a mechanical engineer. I was working in the industry for, well, really about 18 years now. But I was actually up in Chesaning, Michigan. I started out as a firefighter. I was living a block away from the fire station and decided to volunteer.
Cool.
So I've also been a volunteer firefighter for about 20 years now as well. Currently a captain in Troy, Michigan. Believe it or not, we are a volunteer department down here, 6 stations, 140 volunteers. And really, we were talking earlier, but the most of the state is volunteer. It's 60 or 70% of the firefighters in the state of Michigan are all volunteer.
Wow.
But a couple years ago, actually, March of 2024, I went out on my own. I started doing stash training full time, where I do training consulting around battery energy storage, lithium ion batteries, and electric vehicles, both for firefighters and industry as well.
Gotcha. Okay. Reason I have you on is because I interviewed someone in the thumb part of Michigan. For those of you not watching from Michigan, Michigan is a thumb, and there's an area right out there, and very small community. 500 residents live there, and they're redoing zoning to have or consider. Well, they are having one little project of battery store. What's the official name? Is it battery
It's a,
storage?
it's a battery energy storage system.
Battery energy storage system. I'm going to bring it up on the screen, a picture. Is this a fair representation of what they look like?
Yeah, it's pretty fair.
I think this is in California, probably. I see mountains in the background. Okay, so if there's a site, is there not, how many are on one site? Like, is there eight or nine, or does it just depend on?
It really depends on the site. There's one up in Standish, Michigan. I think there's 8 on that site.
Okay.
I just did a story on one in California where I believe there were 84 on one
Wow.
site. So it really depends on the location.
Okay. So they're also proposing them in cities and townships throughout the state of Michigan. And explain, I guess, first of all, what are they? Because the name makes sense, storing energy. But go a little deeper in that. What are they? How are they useful? What are they needed for?
So traditionally, a battery energy storage system, or BESS, it was tied to wind or solar, because wind, solar, it's not producing energy all the time, and they need to store what's being captured from the sun or from the wind itself.
Yeah.
Now, what we're doing is we're tying these into the grid, because we're trying to use. They're trying to do a lot more of this, wind and solar power around the state. They're shutting down our natural gas sites, our coal plants, and they need to have a more consistent way to shore up the grid. So these battery energy storage systems are going to a location, and what they're doing is at night the grid can charge the system up, and during the day when we have peak demand hours, it can discharge into the grid, supplement that grid, because when you're producing power, you want that generation to be nice and flat. You don't like these big peaks in the morning, drop off during the afternoon, peak again when we get home. So what it's helping to do is level off those peaks.
Okay. And I'm not going to get into your issue is not about will solar and wind power Michigan. We're talking about the safety and what they do. So,
Absolutely.
are these necessarily new technology or not been around for a while?
I would say, to the scale we're using them today, they are new technology.
Okay.
Uh, we've had them. I don't know what the earliest example would be, but we definitely had them 2015 on. They've become a lot more prevalent in the last few years.
And the people I interviewed, obviously, they don't know much about them. They're a little concerned. They're worried about them. There have been fires, different places. There's dangers with everything, but are there dangers with these?
There can be if they're not done correctly. And actually, back in 2019, that's when the industry kind of got a wake up call in Surprise, Arizona. There was a fire in one of these systems. It did explode. It almost killed 4 firefighters. It's a miracle that they survived.
Wow.
One of the firefighters was thrown about 75 foot through a chain link fence, Captain Hunter Clare. But the industry learned a lot from that incident. There's a lot of research done on them. And then the safety standards and the codes around battery energy storage systems really started to develop and change at that point.
Okay.
And the codes are really changing at a fast pace right now to keep up with the technology.
What about there there was a fire in Cal. How does a fire even happen in one of these? I mean, how would a fire happen? I don't even know what would spark
Y-
that.
Yeah, so lithium ion batteries, it depends on what's going on in the system, but they can be unstable at times depending on the chemistry, depending on the cell construction. Some of the big fires we've seen in California were just systems that should never have been built. There
Oh,
was one system, for example, Moss Landing. It happened January of this year. It was 1,200 megawatt hours inside of one single building. So think of racks of batteries, almost like a server room, but 2 floors high with these batteries stacked inside. So when there was a failure, it just ripped through that entire structure, and it was a devastating fire. But a lot of what's being built today, and based on the codes and standards of today, the testing requirements, the design requirements, these are much smaller units. So you're talking 1 megawatt hour to maybe 3 megawatt hours in a small, something about the size of a shipping container.
okay.
And the way they're designed and the way they're supposed to be tested is if there's a failure in one of those units, it's supposed to stay in that unit and it's not supposed to jump from unit to unit to unit. So that's kind of what we're going for today. So instead of losing the entire facility, you just lose one container.
Okay. So this is where, and I don't know how it has the regulations. Is that a federal thing? Is that a state thing? Or is it a local thing? Like, what are the, how does that work with the
So
industry
NFPA 855, it's a fire code, and it's the umbrella code around a battery energy storage system that has a
nationwide?
lot of other requirements underneath of it. For example, UL 9540A, that requires a whole lot of testing to be done, including full scale testing.
Okay.
And for example, that's what sets the spacing between the units to say, hey, if this one catches on fire, this one over here is going to be okay.
Okay. So, I guess what would you say to people who are concerned? It sounds like though before they go in, a lot of thinking needs to go into it, a lot of research, a lot of transparency. What would you tell people in communities that are that they're coming now township saying we're maybe rezoning to have this in your area? What would you tell them? What questions should people ask?
Yeah, just make sure it's up to the latest and greatest standards, the newest versions of for example, NFPA 855. Make sure that they're going to have not on-site, remote monitoring for the system. They should have an emergency action plan in place. And they should also be training their local fire department to know what to expect if there is a fire in one of these units.
And as you said, we were talking earlier, is there special equipment you need to buy, or is it more the knowledge that they need to have to
It
battle?
It's really the knowledge and to make sure that it's in a location where if there is a failure, it's not going to be a big event for the community. There are places where I'd say that they absolutely shouldn't go. It's all about common sense. You know, if this is a system that's going up right next to a residential area, it's probably a bad location for it. It should be more in a industrial type area away from homes.
What about, I don't, a lot of the person I interviewed was upset because it was farmland. It was farmland. I guess that is out in the middle of not in a big populated area, but
Yeah,
I,
I would just say make sure that the rule of thumb for me at least 330 feet. That's the EPA recommendation of we'll call it a hot zone if there's a failure. But realistically, probably a little bit further away from homes, maybe double that.
okay. Are we going to see even across the country more and more of these? Especially, I'm here in Michigan. You're in Michigan, I believe, as well. With the push towards solar, wind, alternative energy, is this just the beginning of these going into areas?
I really think with the condition of the grid and the direction they're going with our power generation, that we're going to start seeing more and more of these units, these projects around the country.
Wow. Okay. Um, but the technology is getting better, and the not licensing, but the oversight's getting better. You believe?
I think the oversight is getting better. One of the problems that I've seen, and this is a problem that you see a lot in California, is because of the way these projects are approved and it takes so long for the project to be approved, For example, in California, they're building systems today that were approved back in 2016 that have really no business being built, but they met the codes back then, so they're allowed to move forward. So
Wow.
it's situations like that where there is a problem.
Okay.
But if you're building a system to the latest and greatest code sets as of today, I think for the most part we're looking at a pretty safe system.
But definitely, and you're saying every fire department within that area, they need to know. And I know it might be little inside baseball, but what does a fire department need to know? What's different from that versus a house fire?
Yeah, a lot of what they're going to be doing is just protecting exposures. It's very similar to a substation. If there's a substation on fire, a fire department isn't going to go into that gate and start putting water on the transformers. They're going to wait. They're going to work with their power company to make sure that everything's safe.
Yeah.
Very similar situation with these battery energy storage systems.
Okay.
Now they might be in a situation where they're putting water on an adjacent container. Maybe if we got a really stiff wind, they want to make sure that the flames blowing in that direction they're going to keep that other container cool to make sure they don't have a secondary thermal runaway event. But
Okay.
for the most part, it's just going to be monitoring the situation and protecting.
Well,
Now,
that's why I have you on. I promised the person I interviewed I would bring you on. You are the expert. I will put your website wherever when everyone's watching this. I'll put your website in the link in the comments below. And if anyone has any questions, or if any local municipalities need your help, your consulting, they can just go to your website.
absolutely, have them reach out.